Okay, what I'd like to do is go over some more dimensional analysis problems just for review. And then I'd like to jump into Unit 2. Okay. So are there any questions or anything like that? Any clarifications on the tests that you've would like some clarification on? Okay, so let's okay, so I've got the 3 additional worksheets here. And they're basically, all just conversions that use various, some of them are 1-step, some are 4-step. It just varies a lot. So of these, is there any particular one you'd like me to go over first? Get my calculator out. Now on the test, I tried to give you all the conversion factors you need so you don't have to look up anything.
I'm sorry, I have a quick question.
Yeah.
Is there going to be another link for the Unit 2 lecture when you start it, or is it going to be the same video?
I'm going to try to do it. I'm going to stop this one and then restart it. And then
And you're going to share the link to us with the inbox?
Yeah. Only I'm going to make 2 videos out of today.
All right.
Is that your question?
Yes, thank you so much.
Yeah. Well, theoretically, what I'm going to do is stop after we review a few of these dimensional analysis questions. I'm going to stop the record and it'll make a file. And then I'm going to start it. Then I'm going to click record again and it'll start a new file. And then the new file will be Unit 2. And what happens is Zoom will then create 2 different MP4 files. And then I upload to YouTube. Now I have the same date on it, but it'll be, the title will be reflective of what's inside the video. Okay, well, let's just jump in here. Let's, I don't know. Let's, let's look at this guy here. Let's look at the tortoise. Okay, so what's given? Well, what's given is the number. Look for the number. The number is 200 there. And what are we trying to calculate? Excuse me. Hours. So that's going to go on the right. Okay, so do you know of a conversion factor to go directly from years to hours? There is probably one, but I don't know what it is. So the easiest way is to go multi-step from, and all the year problems on all my tests for the rest of the year will be non-leap year. Okay. Because sometimes when you look up online, like for example, days in a year, for a regular year, they're gonna say 365 point, what is it, 0.25 or something like that days in a year, because it averages out with the leap year in there. I'm just saying it'll be 365. We're not going to deal with the leap year stuff. Okay. All right. So what we're going to do is then convert this to. Okay. Did I do that right?
No, because it wouldn't cancel out the year.
Exactly. Remember, the given always has to cancel. Always, no exceptions. Okay. We're not at hours yet, we're at days. Okay, so we're officially at hours now. So we just multiply everything on the top, divide by everything on the bottom, which is 1, so we don't have to worry about it. So it's going to be 200 365 times 24. Okay, and this is 4 6 figs. So that means this is going to be, oh, it's 4 6 figs as written. And remember, I put the 4SF down just for your clarity. If you'd like to put that down, that's fine, but it's not necessary. I just do it to make sure you understand how I ended up with a rounded off number. Okay, does that problem make sense? I mean, that's a 2-step problem. That's reasonable. Let's do one that's kind of challenging here. Let's see. Are there any questions about that so far?
Nope.
Okay, let's see here. There's one here that I wanted to. Oh, yeah, let's look at this number 1 here. Okay. The sulfuric acid that's in a car battery has a specific density. In fact, in the old days, when we had older batteries, you always had to check the water level in a battery to make sure it doesn't dry out. One of the ways to check to see if it needs new acid, we use something called a hydrometer, which checked the density. And if it wasn't dense enough, we'd add more acid. If it was too dense, we'd add more water. So we get the density just right. And a hydrometer is a little floating device, and it's got a weight in it, and it's calibrated. And wherever the water level is on the calibration mark is what the density is. Now they use those devices, they look like this. And the weight's down here, and it's calibrated here. And they use those in winemaking, beer making. Used to use it, in the car industry with checking the density of your car battery acid. It's used a lot in the food industry and the canning industry, and it's just for checking density. Okay, so density is in grams per cubic centimeter or milliliter. So those are the same thing interchangeably. And this is used in the same problem. They use different ones, but it's the same thing. So milliliter is a cubic centimeter. In the medical community, they call that a cc. And there are so many units to a cc, 100 units. So frequently diabetic syringes are in units, not cc's. Now modern syringes, if you look at it, if you've ever had to give yourself an injection or something like that, sometimes you'll see it as ml and sometimes as cc. And it just depends on the manufacturer. Speaking of water, we may get some rain tonight. Okay, so we want to go from two I like to use milliliters rather than cubic centimeters, but it depends on the book and it depends on your professor. It's just, to me, milliliters, all the apparatus in the lab are marked in milliliters, not cubic centimeters. Physicists frequently use cubic centimeters, and also theoretical chemists will use cubic centimeters, but everyone else, including biologists, we use mLs. Okay. And it wants to know the mass. We want to end up with grams over here. So is there a conversion factor that has both milliliters and grams in it? Yes, that's called density. And they give us the density right here. Okay, so we're going to put the centimeters squared or the milliliters on the bottom. And 1.2 grams on the top. Now that is a measured quantity. So that means it has significant figures, and that's 2 sig figs. Okay, and the milliliters cancel, and it gives us grams, and we want to calculate grams, so it's going to be a one-stepper. So that is okay. You guys jump in if something's weird. Number 2 is a frequent problem that pharmacologists will use at a pharmacy when they're trying to figure out. Also, veterinarians do this probably more than the pharmacy people. They have to predict a dosage based on body weight. So the dosage in this case is 6 milligrams per kilogram of body mass. Now, for example, when I was I had my dog in, and we were trying to calculate the it was an allergy medication. It was Zyrtec or something like that, and we needed to measure the mass of my dog to figure out the amount that we're going to give him. Anyway, so the drug manufacturer will always give you this number here. And they'll frequently give you one for infants, for children, adolescents, adults, and senior citizens as well. Frequently, they'll give you all those because sometimes the dosage is different depending on the age of the individual. Also, male or female varies as well. Okay, so basically, we're starting with a 150-pound person. Let's just make that a 3 sig pound person. The way it's written, you come up with 2 sig figs. Let's just make it 3. Well, of course, the 6.0 is 2 sig figs as well. It's just okay. So we need to go from pounds to what? What are we trying to calculate here?
Milligrams?
Yeah,
Grams.
milligrams. Okay, so we have a conversion factor with pounds and milligrams in it.
Yes, at the very bottom.
Yeah, I mean, we're almost there. Now we just need to go from grams to milligrams. Pounds cancel, grams cancel. So we're looking at 150. Now, if you on the test put down that, I would not mark it wrong. I would put this down instead. In other words, it's not wrong, but it's awkward. And the scientific notation in this case is, in my opinion, significantly less awkward. I wouldn't mark it wrong though, nor would I take off points because the setup is where I was, most interested in, and this would be in milligrams. Okay, did you guys, were you okay with most of these problems on the extra dimensional analysis? Okay, let's do, let's look at the worksheet. There's a couple at the end of the worksheet that were a little challenging as well. I'm going to stop sharing for a second here because I've got to convert the worksheet over to a PDF. So let me stop sharing here for a second. Okay, so this is at the end of the worksheets. In fact, I took this problem here and made it into a test problem. I don't know if you remember that problem on the test. Only you ended up doing years, and I gave you an amount that it rained in 1 year. Anyway, this is where I got the ideas from this problem here. Okay, let's see. Why don't we do number 66? Okay. All right, so basically here we're going from grams per cubic centimeter to kilograms per cubic meter. And we want to end up with okay, so grams to kilograms is pretty straightforward. So let's convert the grams to kilograms first. Okay, that gives us kilograms per cubic centimeter. We want cubic meters. So the deal is we need to have cubic centimeters cancel. So the point is how many cubic centimeters are in a meter? Well, how many centimeters are in a meter? How many cents are in a dollar?
100.
Yeah, so there's 100 centimeters in a meter. Okay, but we have to cube that because the centimeter is cubed. Okay. All right, so now everything cancels, giving us kilograms per cubic meter. Excuse me. All right, so we've got, now I'm gonna, on my calculator, when we get to unit 5, I'm gonna have a different setup on my workstation end. I'm gonna have an additional camera because unit 5 is very mathy, and I wanna, on unit 5, I actually wanna show you what I'm doing on my calculator, key by key. Some of you would benefit from that. Some of you are already quite comfortable with your calculator, but I want to make sure everyone's on the same page. But that's a unit 5 deal I need to hook up. So, okay, so how do we do this? Okay, we have 8.5 times 100 cubed divided by 1,000. So that's equivalent to 8.65 times 10 cubed kilograms per cubic meter. Now, cubic meter is really big. That's why that 8.65 times 10 cubed is so large. Okay, so in this case, what we're doing is we're converting a conversion factor to another conversion factor. So in that case, we still need to cancel what's given. So we need to cancel the grams and the centimeter, the cubic centimeters. And this is going to be 366. Okay, does this make sense? We're left with kilograms per cubic meter. Okay, so I've spent almost a half an hour going over some of these problems. Are there any other problems on Unit 1 you'd like me to go over that were unclear? Okay, this problem 61 is interesting. In the gold rush days in California, and in fact, Klondike gold rush up in Alaska, whenever there was gold, around gold deposits are always iron pyrite deposits, which is fool's gold. And it looks very, very, very similar to gold. But what's different is the density. Iron pyrite, if we look it up, has a density of around 5 grams per cubic centimeter or milliliter, where gold is 19. So gold is much, much more dense than iron pyrite. And that's how, when the prospectors turned in their quote unquote gold, the person giving them the money for the gold would actually figure out whether it's real gold or iron pyrite. And sometimes the gold is actually adulterated with iron pyrite. In other words, the gold grew inside the iron pyrite. So it wasn't a pure sample of gold. So they would give them a portion of that. And they would just be measuring the density of their gold. So what they would do is they would take a container of water. Let's say it was, probably wouldn't be milliliters in the Old West. It would probably be ounces. And they would drop the gold in the water. And then the water would rise a certain amount. And that would be the volume of the gold. And that would be the denominator, the number on the bottom. So this would be the volume of the gold. Okay, for density, you needed mass. So then you'd actually take this piece of gold and actually weigh it. And then you'd have grams per ounce, which would be a density measurement. And that's how they would find out whether they have real gold or not. And you'd end up dividing the denominator into the numerator. So you end up with one, in this case, 1 ounce. And you end up with a number, a converted number close to gold. If it wasn't that, then it wasn't gold. And that was used all the time in the gold country. So if you go to Sutter's Fort, they have kind of a version of this device, a real one, and one of hundreds of years old that's used, and it's pretty cool. Very simple, easy to do in the field, and the concept is what we're studying now, density. Okay. All right, so I'm going to stop. Are there any more questions about Unit 1? You can always email me with a question. If you email me, take a picture of it, so I know what we're talking about. And if you'd like, we can do a separate Zoom session, if you'd like, as well. So always keep that in mind. I'm always open to that. My schedule is fairly flexible because I live by myself. I have my 2 dogs, and there's me. So I don't have a big family to worry about. I'm way past that. So anyway, just keep that in mind. Okay, so I'm going to now